All right, we have a stream going. Let me go ahead and copy the URL into the Discord chat should you choose to follow the live stream. Now, our class is learning ASP.NET Core. And so just as a broad technology that encompasses many pieces. And what we're looking at here is just the Microsoft documentation for ASP.NET. And so, again, we kind of go through the history like real quick. They used to have what was called ASP.NET Framework, and that was really platform dependent. What I mean by that is you had to develop and run the software on Windows machines. Okay, and then some number of years ago, it might have been 2015, I'm ballparking this here, they came out with ASP.NET Core as an alternative to ASP.NET Framework. And the beautiful thing about ASP.NET Core was that it was cross-platform. Okay, and so when we build an ASP.NET Core MVC web application, of course you can develop that on a Mac and you can develop that on a Linux machine, and it can run on those platforms as well. So you can not only develop your software on those platforms, but of course you can run your software on those platforms. Okay, so obviously we are doing the new stuff, which is ASP.NET Core. But as you get into ASP.NET Core apps, again, there's kind of different buckets that you can get into. And one bucket is the model view controller design pattern. Okay, and again, that is the core of what our class is. And what's beautiful about MVC, this was referred to as this design pattern, is that this predates .NET Core, right? I think the MVC design pattern goes back to like the 70s. And so you can take this design pattern and find it in other languages, for example, in Java and JavaScript. And so model view controller is not unique to C# or Microsoft or anything like that. And so what's nice about MVC is that this design pattern is, you'll find it in other languages. So some of you might go off and you get a job, maybe in Java, which is really similar to C#, and in Java they're working with the MVC design pattern, and you would have been exposed to that here. And not only exposed to that, you had a whole class on it. Okay, but then in the newer kind of way of building software, this has obviously been around a long time, this MVC stuff. Okay, the newer approach is what's called Web API. Okay, and Web API is very similar to what a lot of you have done in the JavaScript class, where you build a RESTful API backend, right? And that RESTful API in JavaScript, it was Express, and it services HTTP requests, and it responds in JSON, and all of these things, and it worked with HTTP GET and put and post and delete methods. And so it works with HTTP, and basically what happened is JavaScript started dominating software and software development, and you guys see that in the numbers today. You see that JavaScript is kind of king. And the reason JavaScript was kind of king is they started building these apps where they were you'll often hear the terms microservices, like little pieces of software that are interoperable with each other. Okay, so that instead of building one big piece of software, what might be referred to as a monolithic application, right? A monolithic is where everything is all together in one solution. It's all together in one place. You build smaller pieces of software that might be referred to as a microservice, and a microservice is just built to be independent, but it can work together with other pieces of the software. And so JavaScript started taking over because they started working with they started having this newer architecture, right? They started having this updated architecture that the industry adopted, and that architecture was having a separate backend with a Express web server that worked with web APIs like Express, and then a separate front end like React. Well, Microsoft had to respond, so Microsoft has responded, and they've essentially allowed us to build HTTP API apps on the back end and completely separate front ends built with Blazor. So Blazor was the response to React and Vue and Angular, right? Those are the big front end libraries in JavaScript. And Microsoft came out with Blazor. Now Blazor is probably 3 or 4 years old. Blazor's pretty new. Okay. And so what we're going to do today, again, kind of just looking at the Microsoft documentation as our guide, we're going to start kind of building a HTTP API, just a back end, and looking through this docs. And so as we get into building these APIs, we see right up front that there's 2 ways of working with RESTful APIs. One's called controller-based APIs, and one is called minimal APIs. If you kind of just back up, you can see one link here for minimal APIs and one for creating a web APIs with controllers. And again, we're kind of learning about controllers in this model view controller class, so we can see that some of this stuff will cross over. Like these controllers might play nice in both the MVC design pattern and a web API. But if I go to the overview off the top, we see that there's 2 approaches, a controller-based API and one that's called minimal. So again, this is kind of my exploration with you. I've done some of this before, but I have not done all of this. So some of this is my exploration as well. So allow me to kind of go through it and learn a little bit alongside you. So 2 approaches, controller and minimal APIs. Controllers are classes that derive from the controller base. Okay, and if you followed my video, literally yesterday, we looked at that controller base class. Like we were inspecting the code. We saw that our home controller inherited from controller. Okay, so we see over here, it's the same thing. Our classes are going to inherit from controller. Minimal APIs define endpoints with logical handlers and lambdas or methods. This is very similar. This minimal API is what we did over in JavaScript world. This article points out the differences between the 2 approaches. The design of minimal API hides the host class by default and focuses on configuration and extensibility via extension methods that take functions as lambda expressions. Controllers are classes that can take dependencies via constructor injection, and we'll get into what that means, or property injection, and generally flow object-oriented patterns. Minimal APIs support dependency injection through other approaches. Okay, so takeaway, there's 2 approaches. They work a little bit differently. Like that's kind of what I would take away from that. Here's sample code for an API based on controllers. Now, full disclosure, this is not the approach I've used in the past, but I will be interested in looking at this. Here, we can see our class inherits from controller base. And if I'm not mistaken, in the MVC pattern, that was just inheriting from controller. I don't remember it inheriting the different parent, but pretty close. But nonetheless, this is a class. That class has some data here. This is a constructor of that class. And here's a get method that belongs in this class. It's a public method. And this looks like this is going to allow us to access this via an endpoint, an HTTP GET endpoint called Get Weather Forecast. So I don't know because I haven't done this, but it seems to me like it might be localhost / Get Weather Forecast, maybe. would be the URL. And then it returns some of the data, right? So this is just going to send back probably some data out of this endpoint, right? Looks like at the end of the day, we're sending back an array of data, which is like, look at what we're doing here. I don't think what we're doing is the most important part, but here we're sending back a range between 1 and 5, and we're selecting 1 and instantiating a weather forecast, a new weather forecast, which looks like the base name of this controller. Again, that we're not doing this one this time. Just, okay, glancing at it. Here's how a minimal API might look. The following code provides the same functionality in a minimal API. Notice the minimal API approach involves including the related code in a Lambda. And so this looks app.get, like this looks like Express. App.get / weather forecast, pass in HTTP content and return the data to an array. So this looks a little more familiar, and this is what I've done on this side of the .NET world. This minimal API, which again, this is what we're going to create today. Both API refer to the following class. So this is just a C# class that we'll have to create. Minimal APIs have many of the same capabilities as controllers. They support configuration needed to scale, handle complex route, authorization, control content. There are a few capabilities available with controller APIs that are not yet supported by minimal APIs. That's interesting. So these are the capabilities that controller APIs can do, but minimal APIs cannot yet do. No built-in support for model binding, validation. Okay, interesting. So it does seem that there are a few, there's a list of features here that controller APIs might be the better choice just for that reason. I don't really know. I don't have an opinion there yet. Okay, so that's just kind of, if I look at, again, I'm going back to the home page, and we just kind of hit the overview. All right, the next step is where the exercise is going to come in today. Create a minimal API with ASP.NET Core. Okay, and so you can kind of see there's different endpoints. There's a bunch of gets, 3 gets, endpoints, a post, an update, and a delete. I mean, the exercise is pretty straightforward. We're going to create an array of to-do items, just like we did in Express. Do you guys remember? Like, we just had a local array, and we performed CRUD operations on the local array. I mean, the learning exercises are the exact same. It's just in a different framework, right? So you're going to see a lot of similarities here. I'm going to drag that over, and I'm going to boot up Visual Studio. I'm going to create a new project. And you can see I've actually selected the template on my recents. But let me show you guys how to find this. We're going to select C# and we're going to select Web API. And even within here, all these different options, and this is not it, because it's not an empty one. Interesting that the empty one isn't on there. So I'm just going to say web. That makes no sense to me, but who am I? Here's ASP.NET Core empty. And I think the difference, as you know, let's just explore this real quick. I'm just going to call this we're just going to call this web API exploration. And we're going to call this the name of the template, which is ASP.NET Core Empty, without the spaces. ASP.NET Core Empty. Okay, I'm going to spin up a project of both and just look at the differences between the templates, because there's a million templates and just kind of like, what are we looking at here between all these templates? And again, I default to .NET 8 long-term support versus standard support. This is the new stuff, .NET 9, because every year they're going to come out with a standard, but every other year is when they have long-term support. So I think it's the even version numbers are considered long-term, and those actually stick around. The standard term support doesn't stick around as long. So, you know, maybe we change to the newer stuff, but I'd kind of default that. And I also uncheck configure for HTTPS because we get into web certificates and all that stuff that causes more problems. Just in development, this is not production. So, okay. Let this spin up and I'll yeah, Web API Exploration was the name of the solution. And then the project was ASP.NET Core Empty. So again, just kind of looking at the differences here, it is empty, which comes with the program CS, pretty basic. Okay. Now, like in our JavaScript world, you know, this looks very much like Express, right? We build a variable called app. We instantiate Express. In this case, we instantiate a web application. We say app.get method. This is an HTTP get. When you get the root, it returns a lambda that is just returning a string called hello world. When we boot that up, hello world. Okay, so that's cool. But let's just, while we're here, I'm going to right click the solution. I'm going to add a new project. And I just want to look at one that actually comes with some pre-built code, right? So that's the core empty. But I'm going to go back to the web API. And here's an ASP.NET Core web API. And this says a project template for creating RESTful web API using controllers or minimal APIs. Again, we learned that those are the two approaches with optional support for open API and authentication. So as you might guess what I think, I'm just going to call this web API. One was called empty and this one's just called web API. I'm going to leave all the same. Open, I guess we can leave that checked. I don't think that's going to hurt anything. And oh, here's one for using controllers or not. I'm going to uncheck that for using controllers, because I think it's going to be a little bit more similar to our other project if we uncheck that. Let's spin that up. Let me close those documents. And I can right click here and change the startup project, right? So the web API is now my startup project. I can tell that's because it's bold, right? The empty is no longer my startup, but it's real simply changed by right here. And or you can change the startup project right here in this drop-down list. Okay, now to look at these files, what I want to point out here is a file called webapi.http. This is Postman. You guys remember Postman? Sending HTTP requests to our application. They actually have this, and I don't know when they released it, but I do know it's a kind of a feature now built into Visual Studio, where you can send GET requests to a backend server. So just pointing out that file, we'll come back to that. We don't have to do that right now. Let's look at program CS. A lot more going on with program CS, right? This is kind of a full template. So notice here's our array with some strings called summaries. And it looks like when I hit this weather forecast endpoint, when I hit this endpoint, it's going to return. Hello. Oh,
Sorry.
you're fine.
I'm looking for Henry Gooding.
Henry? Henry, hi.
Ooh, you in trouble.
You're good. So as I'm looking through what this endpoint's going to do, probably a random next shared, it's going to return some of this data. Oh, it's just making up some number of days into the future with some random number. Okay. Nonetheless, we're going to hit this endpoint and return something out of here, something out of this array. And what is this? This is a method called weather forecast. Where do we call that? Okay. It's a, okay, so this is called a record. So we're instantiating a record. I left that checked. Yeah, I left the open API support in there, which you can kind of see line 35. It does something with that. But let's just spin up this one, this web API that again is from a template. Now this is interesting. It actually gives us, this again is similar to a postman. It gives us a GUI to make a GET request to /weather forecast. So again, this is a web interface similar to Postman. If I call GET, you could see the JSON that it returns. 116, temperature 0. But what I just implemented there was a GET request to a backend endpoint /weather forecast. That weather forecast was declared right here. Okay. Don't worry about it right now. I mean, we're not using the templated one. We're not using this web API. Instead, we're kind of starting from an empty. Okay, and obviously this is a lot less intimidating when we're starting from empty. And so let's continue. Now, following a tutorial, okay, there's a couple of options in our to-do. So let's spin up one more project. Right click, add a project. I'm going to choose the empty again, but I'm going to choose some different options. Our project name is going to be to-do API. And this one does choose the .NET 9. So I'm selecting the different framework, and it does leave HTTPS, create. Now on this one, because it's HTTPS, let's change this to the to-do API. Notice this is HTTPS instead of HTTP. Now if you spin it up, you're probably going to get some certificate warnings, and you're going to have to say yes. And then you get this, and you have to say yes. Okay, and then we get hello world. Okay. Okay, next step is one is to add some dependencies. Dependencies in the Microsoft world. Remember in JavaScript, we had npm, right? npmjs.org. npm was how we brought in dependencies, right? Code that other people wrote, that's a dependency. So npm in JavaScript is called NuGet. The package manager in this framework is called NuGet. So we're going to click on Tools, NuGet Package Manager, and we're going to click on the GUI. So there's a console. Just like in JavaScript, we can install packages from the console, but there's a nice little GUI over here. We're going to click on Browse. And there's a button here to include pre-release. Again, kind of everything if you're working in .NET 9, you know, pre-release is like this is the new stuff, which is kind of cool. And we're going to type in Microsoft Entity, okay. Microsoft.Entity Framework Core dot in memory. An in-memory database provider to be used for testing purposes. You know, we're going to be basically, you know, working with either it's an array or anything like that. I don't know if you could just search for dot in memory. Let me see if you just search for in memory. A lot of times these searches, okay. If you just search for in memory, it looks like the top option is the same. Okay, then what you do is you click on To Do API. So you got to check your project, or you can install it on all of them if you really want to, and you click Install. So we are installing in memory, which, as you can read, an in-memory database. We're going to be working with some data, whether that's a live database or just in-memory is like storing it in RAM, right? You're storing this in RAM on the server, so that's cool. We're going to click Install. We're going to click I accept. Which, by the way, we'll be adding packages in this class. You'll get used to it. It's the first time you're seeing it here, but it's normal to do.
Seems easier than NPM.
Yeah, it's got the GUI, right?
The GUI.
Mm-hmm. So now we can close it. We got the green check mark, meaning it's installed. And I'm just gonna kind of focus on this one here.
Why do you call that a GUI instead of GUI?
That's very normal for people to, yeah, just pronounce Gooey.
I've never heard of it.
Yep.
How about button?
I don't know. I didn't make that one up. I promise you. So in the project folder, create a C# class. So we're going to right click. We're going to right click the project. We're going to add a class. Add a class. Capital T, lowercase d, to do. And we've got 3 auto-implemented properties here. One is obviously the ID for the unique identifier for to-do. To-do number 1, to-do number 2. They're supposed to be unique, no duplicates. A nullable name, it's nullable because you got the question mark on the data type, and a true or false is complete property. Now a fun little hotkey for everyone to learn is if you hit prop, just type in the word prop, and then hit tab twice. Actually just tab once, right? So check that out, right? Fun little hotkey, prop, type tab once. So you could see that it's a code snippet. It's this property code snippet. I'm gonna hit tab once. You can change its data type, maybe string question mark. I'm gonna hit tab again. It's gonna put me on the name, last name, enter, enter. Prop tab, double tab, salary, enter, enter. So these auto-implemented properties have a nice little feature, but I'm not adding those, right? This is just showing you how you can quickly type auto-implemented properties. This is often referred to as the model. A model is a class that represents the data in the app. Sir?
You're using the .NET Core.
Yes, sir.
Okay, I'm having a weird problem with the template. Yours says program CS, mine says program .NET.
Oh, you use yeah, F sharp. You gotta select C sharp. If I go to new project, we're gonna select C sharp. No, because there's F sharp, which no one uses, so they should just drop it. But nonetheless, now we're gonna find the empty. Now it's at C sharp right there. Okay. And next, give it an name called to do.
So what happened over there was, remember, .NET has other languages like F sharp that no one uses, and it's easy if you don't select C sharp as your language to accidentally spin up one of these in an F sharp language. So his file extension was not .cs, it was .fs, which literally no one uses. So it's almost a pretty easy, it's a joke in the world, right? So, okay. Now we're going to create a file. Now what we're doing here with this file, and I can explain it probably as I create it, right click, add another class. This is ToDoDB. And as the name suggests, this is going to help us create and interact with the database. Now to do that, the parent is DB context. Okay, now DB context is not going to be recognized unless you click show potential fixes and bring in the using statement of Entity Framework Core. We're going to learn about Entity Framework Core, but suffice to say that's going to help us tie in our C# classes, like our to-do class, into Microsoft SQL Server database. We're going to have a constructor as such. So this is our constructor for the class. And we're basically here creating a table in our database, is what this line is going to do. It's going to create a table called to-dos with a way to insert, you can call a set block, a single to-do item. Right? So this syntax here will help us create the database and create a table in the database with a way to add data into that table.
What was the command to format again? It was like control V and F.
Highlight a, yeah, I don't remember, but
It's Control K then F.
Control K then F.
A and F.
So hold A, KF, which this is pretty well formatted anyways, but yeah, that. Yeah. Now, on the tutorial, there's a whole add the API code, and there's what we do now. Okay, we basically did a couple of things here. We made a class that represents our data, a single to-do item. And then we made another class that helps us interact with the database and a database table. So now let's close those two classes and let's open up Program CS. Yes, sir.
That set method, that's just part of like DB context, right?
Yeah, so the question is around set. And I think of this set like a set block, right? Like think of, you know, set and get blocks on a property. So there's a get block and a set block. And so this is, what does a set do? A set is going to insert data kind of thing, or modify the data. It's going to do one of those two operations. And so to me, if as I'm reading this, I know what we're doing here is we're creating a table called to-dos and creating a way to add new data and modify data with this right here. Now, where does set come from? It looks like set comes from DB context. Because I think that was also in your question, which DB context is the parent that we're inheriting from. Okay, now program CS, again, kind of, I'm gonna do this maybe a little bit line by line, because I'm following the documentation here. The first thing we're gonna do is bring in Entity Framework Core. We then have the builder, var builder. And here's a line. This is a little different. I haven't done this one before. Exactly this way. But here, in other words, it's interesting. So we're not actually creating a real database. We're just creating a database in RAM. Okay, a temporary database, if you will. I've always just created the real database. Okay, so I've done similar things, just not in memory. This goes with it now. I'm gonna control dot that and see if I get anything. I don't think that, no. Okay, are you guys erroring out on this line right here? Yeah. Now I do have this line using statement. I don't think that's doing it. Okay, I'm not going to fight this battle right now. This is an exception filter I'm not so sure that leaving that off is going to be critical. It might, but let's just try leaving it off. We then spin up builder.build. And the first method is at the endpoint to do items. It passes in a to-do database called DB. And then we hit that database, the to-dos table, and return the to-list async. Now we don't have anything in here, right? Like that's the thing yet. We haven't put data in. We don't have any seed data. So that's so one way, since we don't have any seed data, my next thing is to let's do the post. So here, if we get /to-do items, it returns the database. But if we post and we send it a to-do object, it'll add it to that. It'll add that to-do object to the database and call save changes. So I think those two will allow us to kind of get started with this. Just adding an item and then getting a list of items. Yeah.
What did you name the first class you made before the to-do database?
The first class was just to do with lowercase d. The other one was to do db. All right. Okay, if you run the app, the browser displays a 404 because there's no longer a root endpoint. The post endpoint will be used to add data to the app. Okay, maybe just bring that back, and I'm going to say, I don't want that. I'm going to say, welcome to my to-do app. Wait a minute. Yeah, okay. Okay, so here's my to-do app. So far, so good. Yeah. Yeah, let's see. Mine, yeah, I know it's confusing because we did a bunch, but to-do API is the one that I'm currently working in. Yep. Now, again, another tool that's very similar to Postman is called Endpoints Explorer. And so this is in Visual Studio. So this is not a window that's open by default, and we have to open it. So we're going to open it by clicking the View menu, Other Windows. Okay, here's Other Windows, and we're going to find Endpoints Explorer. Okay, and here we have 3 endpoints, and it notices our get, which is a root, our get, which is to do items, and a get, which is a post. I'm going to click on this post, right click the post endpoint, and select generate request. So right click post, generate request. And notice that file that's .http sends a post, which it looks like our host address is 7223, posting to do items. what you do is you have to open up Endpoints Explorer. Did you open that up?
Yeah.
Okay, so then did you navigate to where you see 2 gets and a post?
I have one get.
Okay, did you code these blocks of code right here on your program CS?
I mean,
Okay.
well,
Okay. If what I would recommend, guys, is if you're falling behind a little bit, I gotta move along, and so watch the YouTube stream. You can rewind a little bit on the YouTube stream.
let me just screenshot my code.
That's totally fine as well. Okay, a new file is created called todoapi.http. I'm gonna hit Control S to save it. The first line creates a variable that's used for all the endpoints. The next line defines a post request, line 3. The triple hashtag is a request delimiter. What comes after it is a different request. So this would separate requests, like this is just one request, and if you want more requests, you can add more requests after this. This is just one request, the post. The post needs headers and a body. So this is an HTTP request, so you got to send headers and a body. To define those parts of the request, the following.
So I just have the code. You said you right click the post.
Yes.
Then
The post request needs header and a body. You right click the post and generate request. The post request needs header and a body. To define those parts of the request, add the following lines immediately after the post request headline. So we got content type. Now, so notice the content type that we're sending. We're sending JSON in our post, and we're sending a name of walk the dog and is complete if true. This is a to-do. This is a to-do item. Now it's interesting, name is not capitalized, right? If I kind of go to my class, name is capital N. I kind of would have expected this to be capital N, but nonetheless. Okay. So I think the app is running. I'm going to click on save. I'm going to click on this to run the app. Okay, the app is running, okay, in localhost. And now we can send the request. And did not get, I wonder if that one line is breaking. I'm gonna, now send the request was successful. Send it again. Oh, there it goes. I had to, for some reason I had to click twice. It says 201 created. So this is a success message, right? This is a 201 is a successful. 200s is success. 201 means created. Literally in our program CS, results.created, this returns a 201 HTTP code. So results.created sends that back. And, oh, it did execute twice. For whatever reason, I didn't see it, but I see ID 2.
How'd you open that page?
I click send request. I didn't hear you. Where did web API generate from? Where did web?
She's talking about the second one that we made.
Oh, that was back when I was this one right here. I'm sorry. Yeah, this is the one that was templated. These two, if I just kind of minimize these, this was empty and this was empty, and this one was a template. Right? So I created 3 projects just to explore the different settings. And that's what that was. Okay. Now just like we did before, If I right click this and generate request, notice here's a second one that'll get all my, this will send a get request to get all my to-do items. So if I hit send request here, notice I click the button twice, I'm getting walk the dog twice true. Hey, we're working.
I'm getting an error for when I click on send request.
Okay, I'll help you here in a minute. Now what is left to do is to just, well, fill in the rest of the methods. And again, you can follow my code along, or you could follow the docs. If you're following the docs, it's a lot easier. So if I start filling in additional methods, and we can explore each one. Right, here's two more. Here's two more methods. Notice here, if I get all the ones that are marked as complete, notice our link query is hitting the table where the to-do item T is complete as true, right? So this is only going to get the to-do items, obviously, that are marked as is complete equals true. Right now, we've got two of them that are marked as complete. So if I save this, I'm going to go back here, save this. I wonder how to refresh this.
There's a little refresh thing.
There's a little refresh thing. Now I've got 5 endpoints. And if I generate a request for this, you see how this is going. We're hitting the endpoint to-do items complete. And if I send that request, sometimes, oh, why is this not working? Because we're not doing hot reload. We're not doing hot reload. So let me close it all down. Let me boot it back up. It didn't recognize those endpoints because our server needed to reboot. And so I come back over here and I'm going to post. I added ID of 1, added ID of 2. Now if I get all the items, we get all the items. Now if we say get all the ones that are completed, now if I go back here and I'm going to mark my third one as false, see that, right? We're going to send request. Now is complete as false. Of course, hitting this, I don't return that one. We can get one by its ID. So let's generate the request. And let's send the ID of, now the question is, do I do like this? Maybe yes, maybe no. Let me save. Let me reboot. And let me send one request, send 2 more. And now let me get the ID of 3, and I'm putting it in curlies. Didn't like it, so let's send it just as such. I think that makes more sense anyways. There we go.
You get the to-do items complete and ID.
I am looking at the documentation.
I'm lost. I have an error. I can't
You're gonna have to watch the YouTube video and catch up, or just wait for me to finish, okay? So we can add an individual to-do item. What about an update? I just want to finish this, that way everyone can move on, okay? So what is an update? An update, of course, is a put. Okay, so we have to give it what item we're going to update. We read out of the database and say, hey, it's not found. If you can't read the item out of the database, return not found. And then update that individual to do. So here, line 38 and 39 is taking in a to-do item, and we're updating what's in the database, line 34, with the data that's sent in into the method, on line 32 in the parameter. So here's the actual update that's happening. And then we call save changes. And then notice the results return. If you get all the way down here, it's a success. But the convention here is interesting. No content is a 204. 204 is successful, but you're not sending the data back. It's actually, and I understand, it's considered bad form to send the data back in like clear text. Just give them a success. Hey, it worked. Just give them a 204. It worked. So let's save that. Let us reboot. Okay. Now let's go into here. Let's go to our endpoints. Let's walk the dog true. Let's walk the dog true. Let's walk the dog false. And this is just in RAM, right? So you gotta regenerate the database every time. And now let's generate a put. With a name of wash the car, comma, is complete to true. So we're going to update 3. We're going to update 3 from walk the dog false to wash the car true. Oh, look at this. If I leave that syntax here, I could just put the ID right here. So this is your variable ID. So we're going to ID of 3 it. And let's send that request. Nope, didn't like it. So I want to, huh? I don't know. But if I just go like this, I bet you that. What does it not like? Here, failed to read parameter. Okay, so let me make sure. Oh, is complete might need to be in quotes. And name might need to be in quotes. Okay, 204 no content. That's actually a success message. And if I get to do item number of 3, wash the car true. Okay, so yeah, it's still JSON, so it does want the quotes on the left-hand side. And again, I find it a little surprising, just being honest, that this is the syntax of name and is complete without being like properties. Nonetheless, what else do we have here? Delete, of course. Last one is delete. And so back to program CS. And let's do a delete. The syntax here. Let's find the ID in the database. Find asynchronous. Okay, if it finds it, it converts it to a to-do object. And it calls a remove method. Saves the changes and sends back a no content 204. Otherwise, it returns not found. Results no content. Results not found. Pretty easy once you get the swing of it. Again, maybe a hot reload. Hot reload on file save. Maybe now it does a hot reload for me. Maybe. And let's see if I can refresh. Here's my delete. Generate request. I'm gonna delete. Let's get all the items again. So up here, get all the items. Let's delete the duplicate wash the car. So let's delete the item of 2. If hot reload worked for me. 405 method not allowed. No. So hot reload didn't really seem to work for me. Let's reboot. Maybe if I boot it this way, hot reload on file save. Maybe I have to check it beforehand. Okay. Walk the dog false. Walk the dog false. Walk the dog false. Delete. 204 no content is sent back, so we remove the second walk the dog, I believe. And now if I go to get all of them, we got ID of 1 and ID of 3. Yes, sir.
What happens when it does say like not found? The result is not found. Does it just like return some text or something, or like does it say?
It's going to be a message up here in the status. Yeah. So the question is, what happens if it's not found? So let's test it, right? So let's go to do items 20, right? So let's try and delete a 20. Doesn't exist. 404 not found. Yep. Okay, so we've tested all the endpoints, all the gets. We've got 3 gets, a post, a delete, and a put. We've done the same thing, right? We put some data in working memory and, you know, have all these endpoints. Yes, ma'am. Yeah, program here. Yep. On the which one do you want to see? The put? We've tested that. We've tested delete. And we're almost done with this tutorial. There's a little bit more here.
I just posted all the API routes in the 115
Nice.
chat. So
Thank
if
you.
anyone's missing anything, you can get all the APIs we just did.
Yeah. Copy paste will help you out. The sample app code represents the to-do items URL prefix. Oh. APIs have groups. Yeah, I've seen this before. APIs often have group endpoints with common URL prefixes, and map group method is able to organize such groups. Okay, so notice everything here is repetitive. To-do items, to-do items, to-do items, to-do items, to-do items. So that's your prefix. You know. So why are we typing to-do items? What we can do is make a group called /to-do items. So scroll to the top for me, and right under our builder.build, we're going to create a group, app.group, map group /to-do items. This is called to-do items. And then what we do is we just replace the word app with to-do items. So this becomes, actually we can keep our, we don't have to, the home route's going to remain the same. But here we could do to-do items, map get, and now you just do that. So now this becomes /to-do items, right? And this becomes, so basically you'll get the convention here. So this is to-do items here, becomes this, and then you get rid of this. To-do items here, you get rid of this.
It seems really nice for organizing.
Yeah. To-do items, you get rid of that. To-do items, you get rid of that. To-do items, get rid of that. Right? And so all your endpoints are the same. Like I can, right, save this, and let me just, again, I don't know if it's really doing a good job of, okay, it is. It's hot reloading for me now. So there's idea 4. So I just changed that little bit of code. Functionality, it's all just the same. Functionality is just the same, but it does change the source code a little bit and makes these routes a little, I don't know.
If you refresh your endpoints explorer, it kind of shows what it does, because it'll add like another part to the route. At least on mine it did. Interesting. Yeah, mine does to do items.
Yeah, the endpoints were the same. The endpoints were just the same, but anyways, so that's the map group. That's what that does. Okay, so here's the next step. Here I'm on this typed results API. Use the typed results API. So this is kind of where we are in this tutorial. We got an online guy. Can you check the ID on the var? Okay. Anywho, returning type results rather than results. So these are returning results, right? So look at our returns here. Returning results. Returning typed results rather than results has several advantages, including the testability and automatic returning of the response type metadata for OpenAPI to describe the endpoint. For more information, see typed results versus results. The map HTTP verb, if I can talk, methods call route handler methods instead of using lambdas. Oh, look at this.
I figured it out. I was running the console.
Good.
I don't, but I only have one.
So to save a little bit here, I'm just going to copy. Again, you're just going to have to follow along. But I'm just going to maybe comment this out and update it. So let's look at the update. Again, this line doesn't work, and I'm going to click save, rebuild, and apply. Okay, so we don't have an endpoint root anymore. But notice what we're doing here. To do items, map get. So this is all, the routes are the same. But notice instead of a lambda on the right-hand side here, we just have the name of a function. Name of a function, name of a function, name of a function, create, update, delete. So obviously all these functions are below. And it returns type results, okay, type results, okay. So just a different syntax for sure for doing the same endpoints. And again, what's that?
I think it looks so much better that way.
I tend to agree. It's the structure of the code is, pretty well condensed, and you can kind of minimize this down. Let's just boot this up, save, and verify. I mean, it's all the same endpoints.
Did you just type this down?
Yeah, I just replaced everything that we already did. So again, following the tutorial, you're going to benefit if you open up the tutorial. But let's go back here and let's post a dog 201 created. Good, right? So we're just all that same functionality is there. Getting all of our to-do items now. And instead of returning a results, it's results okay. Results okay. Now, notice these take an ID, so let's do a delete on something that doesn't exist, right? So we just did that, delete of 20. Let's see what that looks like. 404, same kind of response. But if we delete 2, which should exist, it says 204 no content. It says, again, we're just reviewing this. Returning typed results rather than results has several advantages, including testability, automatic returning of the response type, metadata for OpenAPI to describe the endpoint. Okay. So the map code now calls methods instead of lambdas. These methods return objects that implement iResults that are defined by typed results. unit tests can call these methods and test that they are, let's see, I'm kind of like just reading here. It says unit tests can call these methods and test that they return the correct type. For example, if the method is get all to-dos, a unit test can verify. So this would be a unit test that could work with our code now. We haven't gotten into writing unit tests a whole lot yet. Okay, prevent overposting. And we're obviously almost done, which is where we're going to stop. We're down here. Currently, the sample app exposes the entire to-do object. Apps in app production, a subset of the model is often used to restrict the data that can be input and returned. Okay, so we're getting into this concept of a data transfer object, the DTO. Security is a major reason for creating DTOs. The subset of a model is usually referred to as a DTO, a view model or DTO. DTO is used in this article. DTOs can be used to prevent data from overposting, hide properties that clients are supposed to view, right? So if your database has a salary property and you might not want to expose the salary property to the front end, you can use a DTO to kind of hide that property. Reduce the payload size. Okay, so here we're modifying the class of to-do, and there's like one field that's supposed to be a secret. And so if we write our code the way we have it, we're going to update to-do, basically adding this secret. The idea is you might not want that accessible here. Like if we get all of our to-dos and I say secret is secret is super secret info here. Okay, so now our to-dos have some sensitive information. We don't want to expose that. And what do I mean? Right now, if I send this, we get a secret. Now it says null. Let's take that down and reboot it, because that's what it's supposed to do. If I send that request here, okay, now we're storing a secret. And if I get all my to-dos, obviously we're exposing that to any JSON requests. So all you need is to send a JSON request to our backend route, and you're exposing some secret information. That's where this concept of a DTO comes into play. Back to the tutorial. It says the secret fields needs to be hidden from the app, but an administrative app could choose to expose it. Verify you can post and get the secret field. So that's just what we did. We verified that we could post and get the secret. So now there's a to-do item DTO. So there's a separate class that we're going to create. Drag that over here. And we were going to learn about DTOs in this class, like chapter 7, so whatever. I mean, you guys are seeing these concepts for the first time. It's probably a good thing. Where are we at? Solution Explorer. Add a class. To-do item DTO. And pretty pretty standard. It's the same fields minus the secret. And we have a constructor, a default constructor, and we have a constructor that takes in a to-do item and builds that object. And then what we do is in our app, we use the DTO. And again, this is the very end of it. So whatever, we're going to replace the whole thing one more time. Okay, and let's just talk about the differences. Line 6, we can comment out. Rebuild and apply. Okay, method names are different here. Get all DTOs. Return. Here, we're returning a to-do item DTO. This used to return a to-do object. Now we're just returning to-do items. So let's refresh. All of our routes remain the same because they're to-do items. Let's look at the get completed, get all, create. Notice when we create, we still create a to-do item. It might be a flaw in their code because I'm noticing their to-do item does not have a secret. But they've essentially extracted that away from it. It's interesting. I would have expected allow you to insert a secret, but not then display it, is what I would have expected. Okay. That took a little chunk of time. But I think we can stop there. The point was to introduce like RESTful APIs on the back end. This is called minimal APIs, and this was a good little crash course. Yeah, I'm gonna put this on the playlist. Okay.
I think we need to watch it one a couple more times. I got really stuck once I started.
Well, guys, all I really did was follow that tutorial. And look, if you learn better from that tutorial, you can follow the tutorial. If you want to watch the video, watch the video.
I try to understand it for myself.
Yeah, Paul.
Is there? Oh, I guess there would have to be. Like, how would you interact with like the console of like a web browser, like using stuff like this?
How would you interact with the console of a web browser? So we still have to build the front end. So I think, yeah, that's when you get into Blazor.
Okay.
Yeah. And what's really something really fun to do, I want to boot up a back end in Express and a front end in Blazor. These technologies they play nice together, right? Because that's the whole point, So last summer, I went to a conference and just talking to different real world developers, and we were talking about the different tech stacks, and that's exactly what they said. They said, yeah, you should boot up a back end in Express and a front end in Blazor, or vice versa, a back end in .NET Core and a front end in React, and they were like, just to see it, just to do it, This last weekend, I met up with a graduate, and he did not want to do an alumni interview. He's shy, very shy, but he works at Mercy Hospital. And he does a back end in Java and a front end in React. And so, these tech stacks are cool because they play nice together, but they also, when they're built this way, can be interoperable, interchangeable.
Was he the only one you were counting on?
I mean, there's more. I have work to do. I do have work to do there. It is very similar. Yeah. Sir.